Both of these polynomials have to be combined together, so you'll see I put a plus in front of the 4. I'm not just writing it as 4. And it's a positive 4, so I leave it as a plus 4. But when I divide it out, I end up with one bracket, and in this bracket is 2x plus 1. And of course, you're going to notice something now. And that is 2x plus 1 appears twice. It's one of the factors from each of the two groups. So now, overall, we actually have a common factor that's a bracket. And so now we look at this question as a whole, and we divide out the common factor, which is the bracket 2x plus 1. The remaining parts or terms have to be placed inside, just like when we typically do greatest common factor. They have to be placed, that's what's remaining, they go inside the bracket. And so we have left over an x plus 4. Again, we could distribute to check our solution, or since we have the model here, even though I've split it apart, you might take a look up at the model and see that sure enough, the length is x plus 4, and the width is 2x plus 1. It's exactly what we got by factoring by grouping and then by pulling out the common bracket. So let's put all the parts together. So here we have a trinomial, and let's write down what the trinomial is to start. We have negatives now, so you have to be careful. We have 2x squareds. I want to write down the net amount of x's. Now I say the word net amount because a positive x and a negative x, that's called a zero pair. They cancel. So if you have 4 negatives and 1 positive, the net effect is you have minus or negative 3 x's. We also have 2 negative 1's or minus 2. So this is the trinomial. And this is what we want to factor. We could use the model, but instead we're going to do the steps, and I'll show you the all complete steps now for decomposition. We'll check the model at the end. So the first step when you're doing decomposition is to multiply the first and last terms together. In this case, we get a value of negative 4. Think back to this previous slide where we were multiplying the first and last terms together, and that way we knew that that product would also have to equal, in this case, the sum of the terms in the middle. So now we're going to think of two values that have a product of negative 4 and a sum of negative 3. This is very similar now to the previous trinomial method, but we're not looking at the last value. We're looking at the product of the first and last terms, and now we're looking for two values that multiply to equal this product, but they have to add to equal the middle term. Think for a second what multiplies to equal negative 4. Often you might think of just the positive values first. 2 times 2, 1 times 4, and then make sure you consider the fact that this is negative 4. And of course, if the product's going to be negative, one of these two factors has to be negative. You'll notice in my last example, 1 times 4, if we make the 4 negative, then we're ready to be able to have a sum of negative 3. So 1 times negative 4 will satisfy my product, and 1 plus negative 4 will in fact add up to equal the middle term. Now when we're factoring trinomials with a leading coefficient of 1, we would be using 1 and negative 4 as our solutions in our binomials. This is just the second or third step. Our next step is to replace, using these numbers, we're going to replace the middle term. So now I'm going to write out my entire polynomial from scratch, 2x squared. But instead of negative 3x in the middle, I'm going to change negative 3 into the values of 1 and negative 4. Don't forget the x. So this will be 1x minus 4x. And of course, the original last term of the trinomial is minus 2. So we multiplied, found our values, replaced the middle term. Now you should be able to see something familiar. This is the stage called factor by grouping. Here you'll see we've got the greatest common factor of x. When we pull it out, we get 2x plus 1. And in the second part, and remember what the last step for decomposition is, we should end up with the same bracket that's common so we can pull it out. So seeing that the bracket is 2x plus 1 sometimes helps us. Notice both the 4 and the 2 are negative. So we need to pull out the negative, and what's common is negative 2. And by doing so, when we divide a negative out of a negative, we're left with a positive. And sure enough, when we divide negative 2 by negative 2, we get 2x plus 1, both positive, which is exactly what we need. This is called factor by grouping. Our final step is to divide out the greatest common factor, which overall now is the bracket. So we're going to pull out the bracket of 2x plus 1. What's left over creates our second bracket of x minus 2. And again, we can check our final answer by distributing, or since we have a model, let's go over to the model and look at the length and the width. The length of our rectangle is 2x plus 1, and the width of our model is x. Watch out for the red tiles, meaning negative, so negative 1 plus negative 1 is negative 2. That's exactly what we got using the steps. So now we're going to do a little bit of practice. I would encourage you to write out these questions on a piece of paper and to go through the steps and stop the video, and then maybe in a few minutes go back, check, see if the same steps are followed on the screen. So here you have it. You'll notice I multiplied the first and last terms in both cases to get negative 12. In the first question, I needed to find two numbers that added to negative 4, which would be negative 6 and 2. I replaced that in the middle term. I divided into two groups. I factored out the greatest common factor of each group. Notice in the first question, in the second group, the term was 2x minus 3. I needed to factor something out to create a bracket so I could pull out the 2x minus 3. And of course, what number is always common that I could pull out? Positive 1. So I divided 1 out, creating the bracket 2x minus 3. And now I can pull out the 2x minus 3, leaving me with a second factor of 2x plus 1. In the second question, I was looking for numbers that added up to negative 1. So I went with negative 4 and 3, replaced those in the middle term, factored. I ended up with a common bracket of x minus 1. I pulled it out, and what was left over, 4x plus 3, that becomes your second bracket. And there's two more examples for you. So to wrap things up, here are the steps. And I'll just quickly do one last example. We multiply the first and last coefficients, and then we factor it. We're going to think of all the numbers that multiply to equal 20, and you can just brainstorm here. We're looking for the pair of numbers, though, that have a sum of the middle term. We now use these numbers, so that's step 2, find a pair of numbers that add to the middle term. And then next, step 3, replace the middle term with these values. Don't forget the variable. In other words, don't forget that this isn't just 9, this is 9x. So we now have 2x squared plus 4x plus 5x plus 10. Remember, this is the original polynomial with the 9x replaced. Now we're going to divide this into two groups. Each group, we're going to look for our greatest common factor separately. The first group has the greatest common factor of 2x. We divide it out, and we get x plus 2. Our second group has a common factor of 5. It's positive 5. So I write down plus 5. And we know we're on the right track because we've created another bracket of x minus 2. That's your check. To finish things off, we treat x plus 2, the common bracket, as a factor. We pull it out. And what remains creates our second bracket. Good idea to distribute to make sure that we've got the right answer. And again, the terms in the middle are like. Everything checks out. And those are the steps that are involved. Those are detailed steps. Often with a little bit of practice you can go a lot faster, but those are the detailed steps involved in factoring trinomials with a leading coefficient greater than 1 without using a model.